Ramachandran asks the question, what is visual imagination? Throughout chapter 5, he talks about brain disorders such as Charles-Bonnet syndrome, James Thurber-like hallucinations, as well as enlarged blind spots that deal with visual abnormalities. But before we can understand these rare phenomena, we have to understand the concept of blind spots and how our brains are able to fill in the gaps.
So what I would like to demonstrate is a blind spot test, combining some of the different tests that were discussed in the book. First, put the video on full screen on your monitor. Next, cover your right eye and focus your left eye on the X to my left. Now, move your head back and forth from the screen until you can no longer see my head. Visual decapitation is a fun way to find your blind spot, but let's see what happens if I put a horizontal object through it. You should be able to see the left and the right side, but can you see the middle of the object? Or is the middle missing, like my head? If you can see the entire object through your blind spot, it's what is called as perceptual filling in. In your brain, it's assuming that there has to be a middle to the object.
There are a couple more blind spot tests that Ramachandran uses to see how the brain perceives things through the blind spot. There is the two-tone line. This is where there is a side that is white and a side that is black, and when it enters the blind spot, it turns a shade gray. Then there is the spokes of a wheel, what looks like a 2D picture with two eyes, looks like a 3D tunnel with one eye in your blind spot. Next, there's the square with its corner in this blind spot. Basically, the corner does not fill in, but depending on the person, it appears smudged, bitten off, or just disappears. And then there is the offset plus sign. The vertical line lines up, whereas the horizontal line stays offset. And the best guess for that is your stereoscopic vision, which is the three-dimensional vision produced by the fusion of two slightly different views of a scene on each retina. So the blind spot was discovered by French physicist Ed Mariotte in the 17th century while he was dissecting a human eye. And so within the eye, there's the retina where the photoreceptors are located. Within these receptors lies the optic disc. The optic disc is the area where the optic nerve leaves the eyeball and retreats into the brain through what is known as the visual pathway to the occipital lobe. So the eyes relay the image that is formed on the retina to the brain through the optic nerve, since the optic disc is inside of the retina. For the nerves, the area where the optic disc is won't relay any visual information because of the lack of cones and rods, creating a spot in the visual field that is considered blind. So in the V1, it is retinotopically organized, which means that each point that's on the retina has an area on the visual cortex for that point. Does that mean that the blind spot has a region too? Well, it does. It's called the blind spot region. And studies have been done that ask the question, are the neurons that correspond to the blind spot region activate with perceptual filling in when it is occurring during human vision? So there are two proposed theories. The first is cognitive or symbolic, and this is where early visual areas extract only the information at the border of the surface and no information is encoded from the interior. This is the surface of the cortical regions. The second is isomorphic, which assumes that activation is propagated from the edge into the interior across the retinotopic map in early visual areas, and there is pointwise correspondence between the neuronal activity and the interior of the perception. So understanding what is actually happening in the blind spot region is still not completely understood, but scientists are getting closer. So what if your blind spot was abnormally large, larger than a normal person's blind spot? So there are many ways to get an enlarged blind spot, or another term for it would be scotoma. Ramachandran discusses working with Josh, a patient that has a scotoma. He has damage to his occipital lobe, which is the cause of the enlarged blind spot. To understand how the brain fills in, Ramachandran administers multiple variations of vision tests on Josh. With each test given, it was discovered that given the vertical line test, the gaps don't fill in automatically like a normal blind spot, but after a 5-second gap, he actually sees the line slowly fill in. Given the vertical line test again, but using large X's, he was not able to fill in the gap. But if he switched the large X's to little x's, he was able to fill in the gap. So this would indicate that the little x's were small enough to be interpreted as texture, which activates the visual pathway, and the large axes were distinguished using a pathway in the temporal lobes dealing with objects. So another test used numbers, but although the gap was filled, Josh was unable to name the numbers that were in the blind spot. They looked like hieroglyphics. So there was numbers to his, there was numbers 1, 2, 3, and then in the blind spot there was 0 numbers, and then 5, 6, 7 or whatever, or 7, 8, 9. So there was 0 numbers in the blind spot. So the numbers were deciphered through 2 different areas in the brain. The textual aspects of the numbers were in the visual cortex, and the object pathway would react if there were actual numbers in the blind spot. But since there wasn't, it didn't interfere, which the perceptual filling in decided to create these hieroglyphics type number thingies. So it's kind of cool. Throughout these visual tests, Ramachandran has discovered that through the perceptual filling in the visual pathway, it can't make up words or numbers that are real in our world, but are more inclined to fill in with color and texture and motion. So through our basic understanding of neuronal and perceptual concepts of blind spots and scotomas, perhaps they can help us have a better understanding of more obscure syndromes like Charles Bonnet and James Thurber-like hallucination. Thank you.